Hi there, welcome back to the channel. I've got another Starfield video for you. Today we're discussing a question that has sparked a lot of debates online. Just how big are Starfield's planets? And also, how long will it take for us to walk the entire circumference of a moon or a planet? If you landed on a planet and started walking in one direction in a straight line, how long would it take for you to get back to where you started? Well, obviously this is a complicated question. All the planets are different sizes, but I think we can make an educated guess using a formula that could be applied to each planet, the formula being based on the gravity of each planet and moon. So let me throw in my thoughts to this debate. First of all, some of the groundwork for answering this question has already been completed. A clever Redditor recently did some interstellar detective work based on footage from the Starfield Direct. They looked at a display on the HUD during the showcase of one of Starfield's moons, Nemira 4A. The HUD revealed the moon's gravity was about 0.4 G, or 40% as strong as Earth's. And they also calculated the visible horizon to be about 774 meters away. And using some mathematics, they estimated Nemira 4A to have a circumference of around 628 miles. Now that is fairly massive, I'm sure you agree, especially considering that we will be walking or jetpacking everywhere. Now, if we compare Nemira 4A with Earth's circumference, which is approximately 24,901 miles, Nemira 4A's circumference is about 40 times smaller. Here's where we need to make an important assumption before going any further. I'm assuming that Bethesda is not simulating different planet densities in Starfield, only varying sizes. I'm assuming that all planets have the same density, because without this assumption, the task and topic of this video would be impossible to answer. But if it is the case, if planet density is the same for all planets, then we can try to make some correlations between gravity and circumference. Taking the initial estimate of a 628-mile circumference for Nemira 4A, we find that its size is significantly less than Earth's. If we extrapolate from this, we can get a rough estimate of the circumference of other celestial bodies, the planets and the moons, in Starfield, based on their gravity. Before we delve into the sizes, it's briefly worth mentioning how time works in Bethesda games. In many of their titles, like Skyrim and Fallout 4, they use a 1:20 ratio for their time scale, or the amount of in-game time that passes for each real-world minute. This means that for every minute in the real world, 20 minutes pass in the game. So just for fun, I'm going to assume a similar ratio is applied in Starfield. As we delve into Starfield, we're not just exploring Nemira 4A, of course. The game boasts an array of celestial bodies, each with unique gravitational forces. Assuming Bethesda maintains a consistent planetary density across Starfield, we can use these gravitational readings to estimate the size of other planets and moons. Let's consider a celestial body with a gravitational force of 0.2 Gs, or 20% of Earth's. With a weaker gravitational pull, we can infer that this celestial body is smaller than Nemira 4A, and based on our previous calculations, we can estimate that it might have a circumference of around 314 miles. Now, what about a planet with a gravitational force of 0.9 G? This planet's gravity is more than twice that of Nemira 4A, indicating that it's larger. And by applying our size and gravity correlation, we could potentially be looking at a planet with a circumference closer to 1,412 miles. And let's not forget about those celestial heavy hitters with a gravitational force of 1.5 Gs. Given the significant increase in gravity, we could surmise that these planets are considerably larger than Nemira 4A. Based on my calculations, these mammoth celestial bodies might have an astounding circumference of about 2,352 miles. Of course, these size estimations are based on the assumption of constant planetary density across all celestial bodies in Starfield, which may or may not hold true in the final game. I guess we'll have to wait and see. However, these calculations provide us with a fascinating insight into the potential scale of the worlds we'll be exploring in Starfield. Now, what does this mean in terms of gameplay? How long would it actually take to traverse these planetary expanses? A planet with a circumference of 628 miles, like Nemera 4a, would take roughly 105 hours of non-stop running to travel around at a pace similar to other Bethesda games, which is around 6 miles per hour. A larger planet with a circumference of 1,412 miles would take about 236 hours of non-stop running to make it all the way around. And if we apply the 1 to 20 time ratio we discussed earlier, these travel times become much longer in game world hours. It would take about 2,100 hours, or 87.5 days in game time, to circle Nemera 4a, and about 4,720 hours, that is 196.7 days, for the larger planet. Of course, these times would only apply if you were running non-stop. It doesn't account for any interruptions, like encounters with alien life, or simply stopping to admire the view. So while these vast travel times might seem daunting, they also provide limitless opportunities for exploration and adventure. Despite the exciting calculations and estimates, the size of these celestial bodies might not be that significant in terms of gameplay. Remember, the true charm of Bethesda games lies not in the size of the map, but in the richness of content it packs in. Whether a planet is 628 miles in circumference or 24,901 like planet Earth, what truly matters is the depth of exploration, the stories that unfold, the unique environments, and the memorable characters we meet. The sheer variety and detail that Bethesda has promised us in Starfield can easily outweigh the size of the planets. So whatever you make of the estimated sizes, my view is that they do not diminish the potential for profound adventures across a universe teeming with life, surprises, and uncharted territories. After all, we're dealing with a game that boasts 1,000 planets plus, with 10% capable of sustaining life. That's more exploration than any previous Bethesda game. Ultimately, the beauty of Starfield will lie not in the scale of its universe, but in the depth of its worlds, the richness of its stories, and the breadth of its exploration. The size of the planets is just one aspect of this much anticipated space epic. So, there you have it, my best guesses at the circumference of Starfield's celestial bodies, and why ultimately size doesn't really matter. And as we approach the game's release, I'll be interested to see how close these predictions are. Before you take off, remember to like, comment and subscribe. I'd really appreciate it. Until next time, take care.